Now we are going to create piston for our assembly. So as you can see, there are different views given over here to get the proper idea of our part. Important thing is that yeah, this is a cylindrical object, so we will be straight away thinking of creating this part using the wall command. And we have a cut cross section here, and the cross section says that the shape is, if we consider the axis over here, the shape is this. This is what we are going to sketch and revolve. But before going ahead, if we just have a look at this part over here, there is nothing like this over here, right? This face is straight. Okay. If you have a look at this view over here, the region which we are seeing as a cut over here, okay, this section A, this part is also hashed, right? This is hashed over here, and it is not revolving. This part is an exclusion. So while creating the sketch, we will be not considering this much region. We will be not considering this region like this. We will be not considering cutting inside over here. We will be cutting a straight line from right over here till here. And after doing further operations of cutting and adding the geometry inside that hollow space, we will get the final result as it is visible in our cut section. So let's start creating the model. We'll select front plane for sketching the cross section. To create the axis for us, then we'll start creating the section. Don't worry about the shape right now. We'll be adding important constraints and then we'll be giving the dimensions and it will come into the life. This edge, these edges, okay, hold control button, select all of them and say they are collinear with each other. Similarly, these edges are collinear. Good. Let's put on the dimension now. So this outer fin part is 2 units and this groove part is 3 units in height. This is 3, this is 2. Please don't mention the dimension for this edge. It is not mentioned that way. Then we will say that these edges are equal in length with each other. Similarly, these edges are in equal length with each other. It has a separate dimension of 2 units. This edge is of 4 units. This height is of 7 units. Now we will dimensioning rest of the parts and if there is any requirement of geometrical constraint, we will be adding them simultaneously. So we can see the total height is 70 units. This is 62 units. This point is at a height of 65 units. So 75, 65 and 62. So we can select the origin and say this point is at a height of 70 units. Then This is 62 units. This 65 units. Then as we see, this cut, it's right at the height of 45, this extrusion over here. Okay. This part over here greater than height of 45. And select origin, select this edge, and mention the height of units 45. If you notice that all of the horizontal lines are black, that means there is no more requirement of adding vertical dimensions. Those lines are, or those part of the geometry are fully constrained. Now we need to add the diameters and then the radius of this arc. So the diameter is 74 over here and 85 from this edge. We have already mentioned the value of 4. If you select this edge and then click the axis and take your mouse over here, instead of placing a dimension here, if you take your dimension over here, it will be showing the diameter of the dimension 74. Now without clicking anywhere else, just click on this vertical line. It will right away consider this axis. You can mention the value of 85. Just cross check the values first. Okay, they are good. Now the radius of this arc is 189. So our sketch is fully defined. We are good to go. All of the dimensions are correct. There is proper closed loop. This is our axis. Select it and say revolve. We are going to revolve it by 360 degrees. Now we are going to select the front plane and go to sketch, and now we are going to create this outer circle. Okay, so instead of sketching these two circles separately, you can actually create both the circles, but if you plan to create this hole using hole command, then create only this outer circle. So I'm going to use hole command for this inner circle, and I'm going to use extruded cut for this circle. Likewise, I'm going to select front plane and create circle of diameter 36 on it. Which is at an height of 26.5 meters. With respect to origin, the center of this circle is vertically aligned. Using extruded cut through both the directions. Okay. If you select the right plane now and go to live cut section view, and if we turn around, make that face parallel to our screen, we'll be able to see the shape which we are expecting. Don't mind about this region, we are going to create this region right away. So using the same circular sketch, we are going to create an extruded boss. Right now the extrusion boss is starting from the sketch plane, which is front plane. But in our diagram it says that it starts at a distance of 25 units from our front plane. Right? That means these two faces are at a distance of 50 units apart. And they end at a distance of 85 from each other. So there is a bit of calculation over here. We are going to do that. I'll say that extrusion is not starting from the sketch plane, it is at an offset of 25 units. And here the extrusion length will be 85 minus 50, that is 35, divided by 2, of course, because we are creating only the one side of the part. Done. Select this extrude, use mirror command in over here for selection of mirror face or mirror plane. Click on front plane and click on green check mark to finish the operation. So we've got the parts. We'll go to hole wizard. In simple hole, we choose the dimension of the hole to be 22 millimeters. It is of course a through hole. In position, we'll select this face. Just hover your mouse on the circular edge. You will find a snap. Just place your point over there. Come out of the point command by right clicking and clicking on select option. You'll find that your sketch is fully defined. Be sure that point is fully defined and finish the operation. Now if you select the right plane and go to live cut section view, you should be able to see the result as it is expected from our diagram. So this was how we created the piston. I'll add the material into it. In feature tree manager, right click on edit material. Let's say we are going to add an aluminium alloy. Let's say we'll select choose here one. E43 as our material. Save the part. Go into the file properties, custom tab, add in the information to be included in bill of material. Say OK. Save the part to update the information. This is how you will create piston. I hope you understood each and every part of the explanation. If you have any comments or doubts about this model, you can put it in the comment section. We'll be creating rest of the parts in the next video. See you until then. Take care. Bye bye.